right, we are continue our discussion of the important concept, but we do want to illustrate the big idea and the concept with some examples. And for example, here we want to look at there's a particular question related to how do we do this so-called change of the order of the equation. Double integral how to use change order of integration. Okay, so example here, use evaluate or just the same. So sometimes it could be asked like evaluate this iterated integral for y from 0 to 2, and for x, which is from cubic root of y to, well, cubic root of 2. And then the integrand is e to the power of x to the 4 dx dy. How do we evaluate this? Well, if we keep using this order of integration, we would see we need to find of this. Well, it's not so clear how we can do that. And also, we should note, according to this iterated integral, how it is set it up, you can see this domain D in the original form is for y between 0 and 2, and x is between cubic root of y and cubic root of 2. So if we want to plot it, we should see so one. So the integral is treated as this type 2 region, right? We're integrating along each of those horizontal line segment, and the x left is cubic root of y, and here x right is supposed to be cubic root of 2. Why is that? So this point eventually is having a coordinate x is cubic root 2 and y is just 2. Okay, so obviously in the original in double integral formula written in this iterated integral, we are integrating this x variable for the interior integral and exterior integral on this y integral. About it on the well, for the exterior integral, we're integrating the y variable. So how about but that causes difficulty in finding the antiderivative. And then we notice because this integrand is only involving x, so how about we integrate about the y variable first to see what we're going to get. Okay, so if we're integrating y variable first as the interior integral, then we got to leave the x variable for the exterior integral, right? Okay, we got to make sure we're setting it up correctly, but how do we do that? So if we are integrating x as the exterior variable, we need to do this. We need to iterate about the along the vertical line. And before we can do that, we have to fix the domain for the x. And what is this point? This point is having the x coordinate between cubic root of 2. So x is indeed between, for this same domain D, x is between 0 and cubic root of 2. Oh, I forgot the x. Okay, and how about the y variable? Y variable will be starting from 0, you can see, and stopped at this point here. What are the points of the y if x is arbitrary? Well, we got to solve. Remember this curve. This curve is x equals cubic root of y. We need to solve y in terms of x. So this is x cubed equals y. So y is bounded between 0 and x cubed. Now we can write the lower and upper bound for the y variable for the inner integral to this. And obviously, this is given the condition x is bounded between 0 and the cubic root of 2. So this is what we should do. And if we, so this step is so-called the change the order of integration. Okay, so for this, obviously this e to the x to the 4 is constant in terms of y. So we just need to pull it out, and the antiderivative will be just the y. Y will be evaluated at 0, or and x cubed. So this is what we get. And now we have e to the x to the 4 times y cubed. And then subtract well, essentially the 0, because y is 0 for the lower bound. Now we can do what? We can introduce this auxiliary variable u, which equals x to the 4. So du equals 4 times x cubed dx.我正在录 video 啦。
Sorry. Sorry， 我们买了个 cheesecake 了，我想着聪聪要吃呀，让你看一看。这么大一个，24块钱。You just need to tell us how much cheesecake now.
你现在吃呀？
馋的不行了，吃呀。
那么咋吃饭呀？多少钱？
一块吃25块钱。
那还行啊。
下次我觉得还是买2份儿，2个 fancy 的不一样。
对，这个吃的就。行了，
我不打扰你了，不好意思，我们想让你看一看，那我挂了，你录吧。
那你们中午不吃饭了？
吃呀，吃个salad，剩米饭，我炒个白菜去晚上。
要吃点 protein， 多吃点 protein。好，挂吧。